Hello and welcome to this video on composition of transformations. Another way to think about this topic is that we are going to be doing multiple different transformations of geometric shapes all at once in order to go from a pre-image to an image and not only doing one transformation. Some goals here that we're going to be able to do by the end of this presentation is identify the transformations of geometric figures and use geometric descriptions of rigid motions to transform points and figures. A note before we move on, we'll also be touching on dilations, which would not count as a rigid motion in this presentation, so please keep that in mind. Here is the vocabulary that we're going to mention over the course of this presentation. All of these words have been mentioned in prior videos. Please pause the video now if you'd like to look up and define these words in your notes. Otherwise, we will keep moving forward. We'll be combining two or more transformations in all of these composition of transformations, one transformation within another, possibly within another after that as well. So to start with, we'll be looking at some different transformations and trying to determine how these transformations ended up where they ended up. So the first thing we notice in the picture is that our pre-image in black is A, B, C, D. Our first image is A prime through D prime. Our second image is A double prime through D double prime. When you have the double apostrophes, that means double prime, and that will tell you where you are in the sequence of transformations. So if I were to figure out what happened to go from my pre-image to my green first image, well, we kind of see that all the orientation of those points are the same, and we can kind of just slide it down. So that would tell me that it's just going down 5 units. And then we know that the blue image is a reflection. As you kind of see how B prime and B double prime are both 1 unit away from the y-axis. Same thing with D prime and D double prime, and it's flipped directly over. And you can kind of see the answers over on the right-hand side in our table. We are now on example number 2. We are trying to determine what transformation took us from black to green and then to blue. The first thing I notice is that from our black triangle to our green triangle, the triangle has grown in size. So right there we know that that is going to be a dilation. In order to figure out the type of dilation, first we identify the center of dilation. It is always going to be the origin, or 0, 0 right here, unless specified otherwise. If I want to figure out the scale factor, I just need to figure out, well, from this red point, I have to go down 2 and then over 2 to the left to get to B. In order to go from this point to B prime, I have to go down 4 and over 4. That is double the amount, so we have a dilation by scale factor of 2 to get to our green triangle. To go from our green triangle to blue triangle, the first thought, well, it might be a reflection. So if I flip this over to this side across this red line right there, well, my A prime should be up here where C is, and C should be right here across that line. But that's not the case here. We don't have that happening. We have A double prime in a completely different place. So that means that it's not going to be just a reflection straight across. It's actually going to be 180 degrees rotating around the origin in the middle. As you can see how it flips around and it kind of ends with A prime going 180 degrees around and getting to that place. And so we can fill in the rest on our table with those two pieces of information. Now, in this example, we're going to do it from the start just on our own. So first and foremost, we know that the shape in black is our pre-image, and then we're going to green and then blue. So the first thing I would look for is the orientation of my shapes. Well, I can see that A and A prime are directly across from each other. And then there's a little bit of a typo in the PowerPoint. This point right here is supposed to be point D. And then this point would be point B instead. So we'll just kind of keep that in mind as we're working here. So what we were saying before is that this is a reflection, A and A prime, B and B prime, D to D prime, and C to C prime. Each of those has basically reflecting over the y-axis. So we could put a little dotted line down the center here. And you can see how that would be a reflection right across. In order for, so we can write here, we reflected, and then the axis of symmetry in this case would be x equals 0, which would be the y-axis. For our second transformation from green to blue, we see our A value, if we count those spaces that it moved up 1, 2, 3, 4, 5, 6 spaces up, and 2 spaces. It moved 1, 2, 3, 4 spaces up and 2 spaces to the right. So that seems to be the translation that happened there. And you can see how the shape itself did not change orientation at all. It just slid over to the side. So our translation was x plus 2. And the y part would be y plus 4. And that finishes up this problem that we're working on. So let's keep moving to our next part. In this next portion of our presentation, we're going to be transforming points based on their descriptions of the transformations happening to them. And we'll pay close attention to what our point ends up looking like at the end. So now in number 1, we have 3, -2, copied down here. So we have to translate it left 2 and up 4. So that's pretty easy to apply to our points here, because we're just changing our 3 would go down 2 to a 1 for our x-axis. And our y of -2, we have to add 4 to that, making it a 2. And so now from there, we have to reflect over the x-axis. And we're doing that to our first image and not to our pre-image. We're continuing this process. So if I want to continue it, if I'm only going over the x-axis, that means that our x value of 1 is not going to change at all. And our 2 is going to change, and it's going to become a negative instead. For the number 2 problem, we have -1, 5 as our first thing. So we're going to be rotating it 270 degrees counterclockwise and then dilating it with respect to the origin by a scale factor of 2. In order to do this 270-degree counterclockwise rotation, we're going to need to use that rule. So that rule is turning our points instead into a different value. So the point is going to turn into y - x for 270 degrees counterclockwise. So we have to take this -1, 5, and we're going to move our y value to the front and make a 5, and then move our x value to the back and also make it the opposite. So it would become a 1 in the back. So now we're going to dilate this point by a scale factor of 2 with respect to the origin, which just means we have to double both of those values to 10, 2. And you can see that we have kind of adjusted these to be some new values. An added note here for the points themselves. We know we started with both of these at x, y. So if I wanted to say that in terms of x, y for the whole thing, well, I would basically have x plus or -2 over here to the side, and y plus 4. And then I made my y value negative, so that would keep my x -2 the same, and I would make the y plus 4 into -y minus 4. And that would be the general version of what just happened, which is a little bit harder to conceptualize while you're doing it. Let's move on to our next example. So in number 3 and 4, we're going to be working through the same thing by the same kind of process. And we have example number 3, point C is 2 comma 6 is reflected over the line y equals x, and then over the y-axis. So let's start by taking it over the line y equals x. So y equals x means that we're going to be changing our point into y comma x. That means that after that, so we take 2 comma 6, and we are changing it into 6 comma 2. Then next, we have to reflect it over the y-axis. When you are reflecting something over the y-axis, the x value itself is the only part that's going to change. It's going to become negative, the y is going to remain unchanged, which means for us in this problem that negative 6 comma 2 is going to be the answer that we're looking for. In number 4, we're starting out with the point negative 3, negative 4. And I need to first rotate it 180 degrees around the origin and then translate it right 1 and down 3. For the first rotation part, that is going to give us negative x and negative y. Both become the opposite when rotating 180 degrees. And then we are translating to the right 1 and down 3 afterwards. So the first thing that would happen is that both of these will become positive, because I'm going to make them the opposite. And then I'm going to move them right 1, putting us at 4 for the x-axis, and down 3, which will put us at 1 on the y-axis. So for both of these, we've kind of used our points to our advantage, because we have x comma y to start with here. And then we have our 180-degree rotation, negative x, negative y. And then lastly, we have the 4 comma 1 would basically end up being negative x plus the 1 they give us. And then we have negative y minus 3 that they gave us earlier as well. And that finishes up problem number 4, where we have been using just the point and reflecting or translating or rotating all the different transformations on one point, taking it through the points they would go through to get to their second image. So for identifying transformations, we're trying to figure out, based on just the coordinates, what was the transformation that happened. So looking at our answers here in example 1, we have a point going from 1 comma 2 to 2 comma 4. The only thing obvious that happened was that the 1 doubled to become 2, 2 doubled to become 4, telling us that it's going to be a dilation by a scale factor of 2. The only other option would be translation, which conceivably could happen based on just the 1 coordinate. So if it's only 1 point, either could be the case, because we could have said that it could be a translation of +1, +2. But this one also would fit, so both would be acceptable answers. In a double prime in number 1, we see that our points, x and y, switched around. And so we could write that in, that this point right here became the negative y, negative x version of the second point here. If we went from here to here, that's what would happen. Now the only rule that fits negative y, negative x is the reflection across y equals negative x. That was that diagonal line going from top left to bottom right on a graph. In number 2, we have kind of a similar start. We're going from pre-image to a rotation of 180 degrees. So a rotation of 180 degrees, we know, is negative x, negative y. So if your x and y points are only becoming positive and nothing else is changing, the only option you would have would be rotating it by 180 degrees. You could think maybe I could reflect it, but when you're reflecting over y equals x, that would be switching the actual points around, and reflecting over y equals negative x doesn't work because we already saw that that was not going to be the case when they have to switch around too. And translations are usually going to be pretty easy if there's completely different numbers. Generally speaking, it's either dilation or a translation. In this case, we had this one being x plus or x minus 4, and it's also going to be 5 minus 3 is 2. So we have y minus 3. So that kind of goes through the identifying transformations examples presented for us now. We can move into some ones we'll try from the beginning. So first and foremost, in number 3, we have a pre-image at -4, 1. So we see that our y value didn't change at all whatsoever. So that's crucial, because one of the few things that doesn't change y values or doesn't change x values would be a reflection. So the only thing that happened here was that our x value changed from being negative to positive, and our y value didn't change at all. So that is going to be definitely a reflection. And that reflection is going to be across, since our x value changed from negative to positive, it's going to be across the y-axis. Or you could say that that is x equals 1, would be the equation of a line on the y-axis. So second, we have something where the x is not changing at all, but the y is becoming negative. So that's actually another reflection, but the opposite reflection. We're going to reflect over the x-axis. So that is a similar transformation that happened as our second one in that problem. Moving to number 4. So we have 7, -2 becoming 5, 4. So that's a very completely different numbers. So we don't have a dilation because there's no number that gets you 7 times something to get 5 and -2 to 4. No, we can't multiply anything to make that happen. So it has to be a translation. To go from 7 to 5, we would subtract 2 for our x value. And our y value, we'd be adding 6 to -2 to get 4. So we would just do y plus 6. Now for our second part of that problem, we have our 4, our y, going to the front and becoming negative, and our y moving to the back, our x moving to the back and staying the same. If we write that out, we could write that out as the point we have from here to there. We have our y being negative at the front and our x being the same at the back. So there are two options here. This is either a 90-degree rotation counterclockwise, or it could be 270 degrees in the other direction, clockwise. And so that finishes up number 4 for these problems. We're reaching our final 4 examples where we're going to be performing some indicated transformations and ending up with 2 different colors of images on both of these pictures. And then we'll have 2 problems to start from the beginning and try. So first and foremost, we're going to work through each of these and demonstrate all the steps. So the first thing we're doing to this triangle on the left-hand side is reflecting it over the x-axis. So we're going to kind of mark our points here. So our A from our x-axis is 3 spaces. So I'm going to go down another 3 spaces and plot a point for A prime. So I'm going to have A prime being down here. B is 4 spaces down to the x-axis. And so I'm going to go another 4 spaces down to find B prime right there. And then C goes down 2 spaces. So we have a reflection there. And we can connect our points to make our first image. And so we can have that as our image right there. And we can label this with A prime, B prime, and C prime. Now let's move our shape for our second one, and we'll use green. So now from that, we need to translate it 3 units up. So my A prime is going 3 units up to the x-axis. B prime is going 1, 2, 3 units up. And C prime is going 3 units up. And I just need to connect my dots to finish off this triangle. And I have A prime and B prime, and I have C prime, and I've done my 2 transformations. So let's pick 2 different colors over here to do our problem number 2. So when we are rotating 180 degrees, remember that we are going to make all those points kind of follow those rules we've been mentioning. The rule for rotating 180 degrees is -x, -y, and we want to use that to our advantage to make this process faster. So if I want to do this, I might want to label these points. So if I have 1, 2, I have 1, 2 for point E. I'm gonna make that into -1, -2. And so -1, -2. Got my first point. And then we'll go in alphabetical order. So we'll sort of go around the circle, around the shape clockwise. So this was point E for our first shape. And then we have point F. I have point F and then G and D as for our original points. All of these are going to become the opposite signs after this 180-degree rotation. So I have my new point F. I already have my new point E. My new point G would be 2, 2. And my new point D would be 3, 1. So let's plot all those points. We already have E plotted at -1, -2. We have 0, 2 for point F. We have 2, 2 for point G. And we have 3, 1 for point D. So 3, 1 would be right there. So we have our shape drawn in purple. Let's draw that one again. So this one would connect like that, and then we can finish off our shape right there. We finish this off by translating left 4 units for our purple image. And we're going to be translating that into left 4 units. So we'll just go around the shape and do this. 1, 2, 3, 4 spaces. This one would be 1, 2, 3, 4 spaces. And we have this one is 1, 2, 3, 4 spaces left. And we have this bottom one would be 1, 2, 3, 4 spaces to the left as well. And we can connect all 4 of our points. So we have a shape that we spun around 180 degrees and then moved left 4. The slightly neater version of this final answer is here if you wanted to make sure you have the correct thing in front of you or to understand what exactly happened. So take a moment to pause it on the neater version to make sure you have everything correct. But let's move into our last 2 problems and finish this presentation up. Number 3, we are dilating by a scale factor of 2. Well, that's pretty easy. when one of our points is right on the origin. We just need to double the point for B and A. So we're doubling -2, -2 to be -4, -4. And we're doubling 1, 2 to 2, 4. So very easy stuff so far. We just are doubling those points for our dilation, and we have our first image, and we can label it as A prime and B prime and C prime. Now that we've finished dilating our original pre-image to our blue image, A prime, B prime, and C prime, we're going to rotate it by 90 degrees counterclockwise. Remember, 90 degrees counterclockwise is -y, x. So A double prime, we're going to record up here, would end up being, we take -4, 4. Well, the 4 in the front, we'd have -4, because that 4 in the x is going to go to the back, and then be -4 again. So -4, -4, which is going to be down right here, is going to be our A double prime, and B double prime is going to end up being taking 2, 4 and applying this algebraic rule. So that means our x is going to move to the back, so we have a 2 in the back of our point, and then our y of 4 is going to move to the front and become negative. So we have -4, 2 as our point there. So -4, 2 will be right here. And we can just connect those A double prime and B double prime to each other, and then connect them to the C double prime. They never moved because it was just at 0, 0. And we have that as a result for that problem. We're now going to start number 4. We are reflecting over the x-axis first and then over the y-axis. So point G prime would be in the exact same place. We can take D down to 3 spaces on the other side of the x-axis to make D prime. We can take E down 4 spaces and then another 4 spaces to E prime down here at the bottom. And then F down 3 spaces and then another 3 spaces for F prime at the bottom. And we can connect our points to make our image. And so now we're going to do the same thing, but we're going to be moving it across the y-axis. So G prime is going to move 3 spaces and then another 3 spaces over to this side. We have D is not moving at all, so we can connect those two. E prime is going to move 2 spaces and then 2 more spaces. And F prime is going to move 4 and then another 4 to land on that side of the y-axis. And we have finished up this problem. So we'll just do some quick labeling of our new shape of G double prime. We have D double prime. We have F double prime. And finally, we have E double prime. So overall in this video, we covered all that you need to know about multiple transformations happening at once, whether it be identifying them, applying them to points, determining what their transformations are, or by physically doing multiple different transformations to one pre-image or one geometry shape on coordinate grids. Thank you for watching this video.